All right, let's go ahead and get it started. So welcome everyone to today's webinar. I'm Steve Perczynski. I'm a Director of Product Management here at Vast, Product Marketing here at Vast, and I'm joined by Howard Marks and Rob Girard. Today's topic is rapid recovery and best practices for data reduction. So we've had a lot of momentum in the backup space with our major partners. We've got major enterprise customers in deployment with Veeam and Veritas. We've actually got managed service providers building offerings around Commvault with us. So let's go ahead and get kicked off. There's a lot to discuss. Howard, do you want to introduce yourself?
Sure. I'm Howard Marks. I'm technologist extraordinary and plenipotentiary at Vast, which basically just means I've been here forever and I get to explain things.
Awesome. And Rob, tell us what you do here at Vast.
Sure. Hey, Rob Girard. I'm recently been moved into the office of the CTO here at Vast, and I have a focus on data protection and virtualization.
Great. So the way these work is the agenda is really set around your questions. So we've got a set of topics. Obviously, we're diving into how to recover from major ransomware events, how to get the best optimization and efficiency out of your backups. But it's all about today. So please feel free to jump in the chat, ask a question, and I'll ask it to our experts. And with that, let's go ahead and kick off our first poll. All right, so everybody knows that having a disaster recovery plan is absolutely critical, and it's really important to test it before you need it. So let's find out just how up to date we are. Okay.
I liked how for a second there all the answers were within 6 months or you're supposed to test.
I was, yeah, then that caught up real fast. I was impressed. All right, just another few seconds here. And we'll go ahead and end that poll. So, and we need to make sure we can share those results. So Rob and Howard, is this about what you expected?
Yeah, there's the people who are diligent in testing, and there's the people who just never get around to testing. And the middle is usually weak.
Makes sense. Cool. All right, and then let's do one more. Our next poll. What is your expected recovery time?
So now here, folks, we're talking about what you expect, not what you've promised your boss.
Exactly. Long enough for you to get out of the building. It's like 5 minutes. Nobody's picked that. It's like a 5 minutes job in a week. So I think we're taking it seriously here.
There's the first honest.
Somebody took one. You had to do it. Let me go ahead and share those results. So again, yeah, less than 4 hours is pretty good, and that seems to be the majority. Is this about where you guys thought it would land?
It is, but it's a little optimistic.
Yeah, I was thinking it's a little more aggressively optimistic than I would expect, and in reality, in order to land this way. But I think definitions on these disaster recovery, may come into play.
Yeah, I think so too. And so Rob, that kind of keys you up pretty well here. There's a lot more than just speeds and feeds when considering how to recover. So let's dive into it.
Sure thing. So let's just share this out here. And if you can just confirm that you can see it, that's great.
Yep.
Okay, so this slide's intended to cover recoveries in terms of backups recoveries, not necessarily failure recoveries, because in order to hit some of that less than an hour, less than 4 hours that people are looking to target for the recoveries, they're probably doing failovers. And failovers are fantastic. You got 2 sites and you've got everything ready to go. But that's not always an option. And sometimes you got to go to backup. And in case of things like ransomware, it's very much more common to have to go to backup because the known good of the environment has been very much compromised, and you need a clean slate somewhere. So it might be restored cleanly or elsewhere. And in the past, these restores generally weren't for something catastrophic like ransomware that kind of infected the entire infrastructure. It was really smaller data sets, user screw ups on files, asking to retrieve, when you're someone's cruising through vCenter and they mean to power off and delete VM. Yes, are you sure? And like, oh, there, it's gone now. These kinds of things would happen. And it was really quick to get things started to restore. And in the past, moving from tape to like a hard disk based appliance that was intended for backups was great, because you could get that restore going right away. Within milliseconds, you're already starting that recovery versus waiting for that tape to load in a library, or go and fish it out from the drawer or whatever that might be. And today the recoveries are on a much larger scale. If a restore is like, sure, we still have the onesie-twosie restores, but in the case of ransomware, restores are typically very large, big sets of data sets, entire arrays, entire vCenters full of data stores with all the VMs in it. All of the VMs in a logical domain may be infected. So we're no longer looking at time to first byte as the thing. Is we need this stuff up and running, and we need all of it up and running. And so due to the nature of this change in restores, the way that you're backing up needs to evolve as well. Now, when we look out into out in the wild here, I've got a lot of quotes. Hey, it takes a long time to recover. Ransomware is an act of war, but average time to recover is around 21 days. Now that's average. Now the group on this call may be a lot more enterprise focused, especially with the responses around less than an hour, less than 4 hours. But all best plans don't necessarily come out as intended. So it could take quite a while, and what we want to do is give you some tips and tricks here to make sure that doesn't take so long. And so when it comes down to recovering, one of the questions that I find is most overlooked is, where are you going to recover all that data? So we're talking about a lot of data to restore, so you need some space to do it. And these are the options that usually people come back with. First option is pretty much always primary storage. Like, well, it's the copy is no good on primary, so I'm going to restore it to primary. That's where I've got enough horsepower to run it. This is the right place to do it. This is where I intend to do it. But in a time of ransomware, that may not be a possibility. So there could be a hold for forensics or insurance while there's an investigation going on as to how that array maybe got infected. So even if you want to recover there could be some red tape around that says, sorry, you can't right now. You may not have the capacity to do it. And the capacity is often your leading indicator that something went wrong from a ransomware perspective or encryption's used, because that data has been overwritten with the same data, but in an encrypted form that gets no kind of reduction. Most primary storage has data reduction, compression, and dedupe, and all of that goes out the window when you're encrypting things. So there probably isn't remaining capacity. Likewise, with these snapshots that are kind of plan A for recoveries, they, depending on how long ago things got encrypted, may not be available. And those also lead towards filling those systems even faster. So probably not a place where you can do it. New hardware supply chain these days, you're not getting a 4-hour drone drop off of enterprise grade infrastructure to restore to. So if your plan is, hey, I'll just get out my credit card and buy new hardware, it's probably not a very solid plan unless you put that order in already. And a backup device. So what we refer to here as the backup device is when you run it directly from where those backups are held. So Veeam, Commvault, Veritas, many offer some form of instant recovery or live recovery. And those are great small scale, onesie, twosie VMs. They're great to bring up a VM at a point in time, but they really don't scale to let you bring up all your stuff and run from it. It is nice that you can bring things up and start running right away, and then leave it running while you storage remotion that off to that final destination. But if it's only for 1 or 2 VMs, or more than 1 or 2, but a few, that's an okay strategy. But if you're looking at a mass restore, that's unlikely to do it.
So
And then
Rob,
there's
in
the
that
cloud.
scenario, I was going to
Yeah.
ask, in that scenario, you're actually reading the VMs through the data mover itself, or are you able to read it directly from the backup appliance?
So it's through a data mover. It's not through the backup appliance unless the backup appliance is integrated to the storage. But in most cases, we're talking about so in case of Veeam, we have what's targeted as a vMount server. This vMount server will present what they call Power NFS, which is an NFS share out that gets mounted automatically into your ESX host, or it's an SMB share in the case of, or LUNs that can be presented in the case of SQL recoveries or Hyper-V recoveries. And so what we have is a kind of a system in the middle. So even bare metal, I've done a lot of testing around this. Even with a bare metal box there, I'm pretty constrained on number of threads that are used for any particular task. The queuing involved when there is a jumble of requests coming through, like you always see in multiple virtual machine environments, really aren't the same as what you'd find on enterprise grade storage that is intended to serve it directly. And then there's this translation factor as well. So the data is stored in a different format, either an S3 or like a VBK format on disk if it was on NFS or SMB. That has to be pulled, kind of translated to a landing spot, presented to the ESX host. And it's sort of a bit of a Rube Goldberg machine that, you know, at the end, here's this VM that starts booting right away, and it's pretty good. Now, in order to run this, you do need a fast backend. So VAST offers a great target that you can run this stuff out of. It'll give you the best possible you could expect in those scenarios. But even with the zero latency storage backend, you will not be able to go full scale through this method. And then that last method is the cloud. If you've got a nice multi-cloud setup now, maybe this is feasible, but if your plan is, hey, I'm going to spin up a bunch of instances and then put my VPCs together and recreate things sort of in that time of crisis, maybe may have another thing coming. And then once you do that, there could be some sticker shock on those egress fees to get everything back in, because you do have to bring it back to where you were running it from.
And there's almost definitely sticker shock on the effort required to bring it back.
Yeah, so yeah, that's one thing that it's cheap, put it in, and then pulling it back out isn't always the same. Now, in a recovery scenario, a lot of times people are desperate enough that money is no object, but that's usually not the case. But in a scenario like this, people would rather be able to pay and have it back than have no recourse and never get it back, which is why ransomware has taken off so much, is people are willing to pay when that is their last resort, and do like to hope that last resort actually comes through for them. So we hope that your strategy puts you in a position where you never have to pay that ransom. Other considerations around recovery is we commented a bit on it, is how long will it take, and can you test this recovery plan? And since in the poll, and most people are testing a lot, tested 40%, I think it was, tested in the last 6 months, and maybe if people test yearly and we happen to have this session 6 months from now, the other 40% would land on the same thing. But how long can you run in this recovered state? And I kind of alluded that into running straight out of the backup device. That's probably not something you can run sustainably. And then a big one is, is there sufficient capacity to allow for recovery? And it's that last point that I want to queue up a discussion for Howard right after a poll that we're going to do again, but around data reduction and ways that you can find space that you may not have known is there. So with that, I think the next poll that we want to ask you, which we'll stop sharing here, we'll get the poll going, is whether or not your current data recovery plan accounts for ransomware. So after all the things I said, maybe the answers on the first question wouldn't be as optimistic, but we want to see how you're all feeling about your strategies with ransomware right now.
It's looking pretty good here. Yes, definitely, and yes, partially.
There's about a third or the honest, not really.
Really?
Not really doesn't mean none at all. And depending on the ransomware scenario, your current plan may serve you well. Just there's a lot of different scenarios that can happen. So yes, definitely we've got about around 25%, about half the people are partial, and then the other quarter or so is not really.
Yeah. Yeah. So I mean, my takeaway with this is it's more than just, having, fast backups, right? You've got to know where it's going to go. There's a lot of moving parts involved. So definitely important to recover it out. So good. All right. Well, let's go ahead and pass it over to Howard then.
Great. So I'm going to talk today about getting the most out of data reduction and optimizing data reduction in your backup environment. Data reduction essentially was invented for the backup world. Data domain brought deduplication to us 20 years ago. But before we start talking about specifics, I want to be clear about what we mean by best practices. What we really mean, the term best practice really means tribal knowledge. It's things that we as a community have learned are good ideas. And some of those good ideas are just good ideas for all time. The 3-2-1 rule, that you should have 3 copies of your data in 2 locations, with one of them, of 2 technologies, with one of them being offsite, just protects you against a wide variety of failure modes and remains a good idea. But in other places, tribal wisdom is just, we've always done it this way. And as technology evolves, then that tribal wisdom has to evolve too. So, we've used disk to replace most tape, and it's time now to take the tribal wisdom that says flash is too expensive for backups and place it back with tape as something that's a previous, technology has left that knowledge in the ash bin. When we talk about best practices, we should try and remember that what we're trying to do is optimize our system to use the least of the resources that we have the least of. And that might be time, and time is the traditional optimization in backup. I have to get my nightly backup done within whatever the backup window is. That's changed with ransomware, as Rob discussed, because restores are no longer small and ad hoc. They're becoming much larger. And so restore time becomes much more important. Money is always a constrained resource, so we have to optimize for money. We also have to optimize for effort and staffing. There are lots of things you can say, well, we'll just do this manually. But if you don't have the people, or even if you do have the people, the things your IT department can do is a zero-sum game. And if we can eliminate the need for people in places, then that can make those people available for other things. The way we do this is by trading the resources we may have in abundance for the resources that we have that are in shortage. And those resources that are in abundance are frequently going to be off-hour CPU cycles and network bandwidth. And the whole idea of data reduction is trading CPU resources, or CPU and memory, for the space that the data is going to take up. So let's review what we mean by data reduction pretty quickly. There are 3 kinds of data reduction. Compression, the most typical and the oldest, looks for small duplications within a limited range of data and builds a dictionary that says, I've seen this string of 100 bytes, replace it with this 2-byte token. And then when you decompress, you see the token, replace it with that string of 100 bytes from the dictionary. There's another form of compression that gets added on called Huffman coding that reduces the number of bits that get needed. But compression is that combination, small range, small duplicates. Deduplication is kind of the other extreme. We're going to look for large duplicates, And instead of storing an entire set of data 2, 3, or 100 times, we're going to store one copy and replace the other copies with pointers to that one copy. Deduplication is very effective, especially for backups where you might be backing up the Patch Tuesday updates to 1,000 VMs. It's exactly the same data 1,000 times. We're only going to have to store it once. The third technique is exclusive to VAST. It's what we call similarity. Like deduplication, we divide data up into chunks and we apply a hash function, but this hash function finds blocks that are similar, and that allows us essentially to store the differences. And the net result of all of this is that you get additive reduction from each technique. So in short, data reduction trades compute resources for capacity. Compression is pure CPU. Deduplication adds a need for memory to hold the table of those blocks we've seen before, because the system has to quickly recognize, have I seen this chunk of data before or not? Rehydration has costs. Anytime you're taking reduced data and turning it back into unreduced data, that's going to have costs associated. Modern compression algorithms are designed so that compression takes a lot more CPU than decompression, so decompression is very inexpensive. Both deduplication and similarity, you consume IOPS by storing small blocks and having to retrieve small blocks from random locations to reassemble data. You are trading IOPS for capacity. That's a good trade on SSDs that do random I/O just as fast as they do sequential I/O. On hard drives, you're trading restore performance for capacity, and that was a good thing when we were restoring a file because somebody overwrote their Excel spreadsheet when they weren't paying attention. But if I have to restore petabytes of data, then that restore performance being substantially slower than the backup is going to have executive vice presidents breathing down my neck going, is it done yet? The key thing to remember about data reduction in general is that rates and ratios are just numbers. All that really matters is how much storage you have to pay for at the end. So as a user, you shouldn't care how much reduction occurs at any stage in your backup workflow. You should just care about what the end result, how much storage I have to buy to hold my backups is. That's different than what people with agendas will be telling you. So I mentioned you can compress or reduce your data at various stages in the process, and each stage trades and makes trade-offs that may or may not be effective for you today. So the one extreme is source reduction. I can install an agent in every VM or on every host that looks at the data that's going to be backed up, generates the hashes for deduplication, sends those hashes to the data mover or the media server or the backup target, depending on the product we're talking about, finds out which of those chunks the system has seen before, only has to send the new data. That's very effective at reducing the amount of data that needs to be sent and optimizing for bandwidth, but it consumes a substantial amount of CPU at the host. And so if you're running a host where you're CPU bound, that trade-off may or may not be worthwhile. The other thing about software data reduction in general is that software data reduction has to work with relatively coarse-grained chunks because of the limited amount of memory they can consume both by the agent and in the data mover. And so when a backup application performs deduplication, It's generally deduplicating on large chunks from 64K to 4 meg, as opposed to backup targets like VAST, which are going to deduplicate on a finer grained chunk. So if you have a small change to a file, that might be 4K change in 1 megabyte of chunk for this backup application. It's going to be different. And so it's going to store a megabyte of data, even though the vast majority of that megabyte is data it's stored before. If you deduplicate it on 32K chunks like VAST does, you're only going to store 32K of data, not a megabyte. In addition, VAST will see that 1 megabyte grained deduplication and reduce it further through both deduplication and similarity. So the fact that it's less effective doesn't mean that you're storing more data on the back end. It just means that the deduplication or reduction is additive. You can also perform that reduction at the data mover, at the machine that actually copies data to the backup target. Again, this has the same software limitations. It's probably going to be coarse-grained. It may only deduplicate across limited scopes. One vendor, you have different deduplication for different backup jobs. And so if you created 6 backup jobs, data in job 1 that's also in job 4 wouldn't get deduplicated. Targets deduplicate any data you send to them. So if you have a VAST system as your backup target, we're going to deduplicate all of that data. We're going to similarity reduce all of that data. It's going to be fine-grained, and all of that reduction is additive to the reduction you get at the earlier stages. So what you have to do is decide what's going to be the simplest solution that doesn't exceed the resources you have available. Data center networking has become cheap. 100 gigabit Ethernet ports, for the switch and the NIC are down around $1,200. And so you may decide just to optimize the data center network and deduplicate entirely at the target, or you may have some more constrained connection between data centers or between your data center and a remote site where you need to perform that optimization ahead of time.
So I just want to remind everybody to ask your questions in the chat. This is just a great topic. So I want to ask Rob, do we have kind of a rough scenario of how many people are also using all of these things together? So I know you've done quite a bit in the field.
I would say definitely I see data mover and on the VAST side, that's where we're talking.
Right.
Prior to VAST, a lot I've seen a lot that do not have data reduction on them, but yeah, I would say that pretty much every install we've done still uses compression turned on in the data mover and dedupe turned on there. And our best practice around that is to recognize that there's 2 spots to do this. So let your data mover move more data faster by working less. So if it's less fine-grained on its dedupe, then that's fewer calls to a centralized database that has hashes for all of these and can push the overall throughput through faster. So coarser grain, move it up to the largest block size you can on those dedupe boundaries. And every time you do that, most backups apps, maybe all, give you some kind of warning that, hey, this will cost you more space, or something to that effect, where this isn't recommended because you will lose out on space efficiency. But because have many layers, we let that data mover take the lowest hanging fruit, do its job, which is move data, let it focus on moving it faster. But we don't want to eliminate it completely, because it's faster to not move something than actually move something that's smaller. So skipping that move process altogether in the case where it does find a complete duplicate, like an entire VM, coarse grain checked, clone is a clone. And those
or as I mentioned, all the Patch Tuesday patches.
Right, exactly.
That there is low-hanging fruit that even very coarse deduplication will get you a huge advantage on that. There are hundreds of copies of this 20 gigabytes of data. And Patch Tuesday is kind of the most obvious example. The other advantage.
Patch Tuesday is a good one. Just to comment on that is because it gives you both. When that first patch lands to be staged, it's kind of in a compressed format in a large file, and odds are that one might get picked up. But then when that is actually deployed into the OS, it's scattered through the different blocks throughout it. In Windows land, it's Windows SXS, like the side-by-side directory just bloats and grows and grows. And then that stuff's a little blurry, and probably the coarse grain stuff wouldn't pick up that aspect of it. So it's kind of a double whammy in terms of new capacity on those Patch Tuesdays.
Yeah, but all the new DLLs that get written into System 32 end up being adjacent, and so that gets caught. So the other advantage of deduplicating at the target is that you get reduction across multiple sources. We talk about backup environments, and my previous slide showed, well, there's one data mover. Well, I might have 5 data movers just because of scale, but I probably also have data movers from different vendors for different kinds of data. DBAs don't trust the backup administrators to do backups, and so they want to use RMAN to back up Oracle, or SQL Server dumps to back up their SQL Server. They can write to the same target. That data is going to deduplicate with all of the other data because it's on the same target. It also means if you're transitioning from one backup application to another, that you don't have to have separate repositories and deduplicate that data separately. The Similarity engine in the VAST system recognizes data that's been compressed through dictionary compressions, which is basically all of the LZ compression algorithms most commonly. And like we already mentioned, finds duplicates at a finer grained value, so works very well with data that's already coarsely deduplicated. A VAST cluster is a single deduplication realm with very few exceptions. Really, the only exception is if you have multiple tenants who encrypt their data at rest with different encryption keys. Other than that, a VAST system is one deduplication and reduction realm, regardless of its size. Most of our competitors can only deduplicate across a petabyte or 2 petabytes of data. You can build a VAST cluster that's hundreds of petabytes, and it will deduplicate all of that data. Now, there are a couple of gotchas. There are things that will hide data reduction from any data reduction system, including VASTs. The obvious one is encryption. Encryption is all about eliminating the entropy in data before you transmit it. If there's no entropy, there's nothing to reduce. The other issue is Huffman coding. Data that's been Huffman coded has all of the extra bits squeezed out of it, and it makes it impossible to determine what data was there that might be a duplicate of something else. So the recommendations for minimizing the amount of space your backups occupy, which is all you care about because it's what you pay for, is to not encrypt data in the data mover and to use data reduction in your backup application, but not compression that uses Huffman coding, which normally you'd see that as gzip. And our best practices for the various backup applications will call out, turn this on, turn this off. Unlike other vendors, we don't say turn everything off so that the GUI on the VAST system shows the maximum reduction. We are not interested in bragging rights. We're interested in you storing as little data as possible. So feel free to deduplicate and compress with dictionary compression before it gets to us. We won't be able to claim 10 to 1. We'll only be able to claim 3 to 1, but that's fine. So now I said, don't send data encrypted at the backup application to your VAST system because encrypted data is essentially irreducible. We've had a small number of customers who back up a large amount of data with the same encryption key. And that has turned out to be somewhat reducible, but I'm not asking anybody to plan on that. Assume any data that's encrypted before it's sent is irreducible. So to get best reduction, you want to tell the backup application not to encrypt data. But that doesn't mean you don't want to store your data encrypted and you don't want to transmit your data encrypted. Encryption serves important purposes. We don't want people to get access to your data. So you encrypt data in flight by backing up to the VAST target using S3 over HTTPS. Therefore, that data is encrypted via TLS. And the data in flight is encrypted. And if anybody gets access to that data stream, they won't have access to the data because they don't have the encryption key. VAST systems perform encryption at rest using AES 256 and FIPS 140-2 validated libraries. You just have to turn that on. We'll support external KMIP key managers so you can maintain management of your keys. Your data is now encrypted in flight and encrypted at rest, but the data is in the clear internal to the VAST system to perform the data reduction before it's encrypted again and written to the SSDs. We strongly recommend that you use S3 object lock to manage immutability. It gives control over when data can be overwritten or accessed to your backup application, so you don't have to coordinate that in multiple places. So as I mentioned, vendors make promises, and the promises always look like the hamburgers in the commercials. They're juicy and the tomato is clearly visible. But in reality, software vendors use large granularity to minimize the amount of memory that they need to use, because frankly, you would not buy a server with 4 gigabytes of DRAM to be your data mover. And so they have to accommodate that. They have limitations about how big deduplication realms are, so you end up with multiple pools. And frequently, there are other limitations that where the backup software restarts its deduplication and essentially has to do a full backup because it needs to do space recovery or for other reasons. One example of this that Rob wrote a nice blog post on is when Commvault writes to an S3 repository with object lock, it sends the full set of data every time the retention period expires. And that if you don't have a system that does data reduction on the back end, might mean that you need twice the capacity you thought you needed. And that could definitely be a problem. All too often, the reality looks like the sad hamburger that you actually get through the drive-thru. That brings us to the end of our prepared commentary. Please ask some questions. We'd much prefer a conversation than just babbling on like the idiots that we are. You can find more information about how to use VAST for data protection at vastdata.com/platform. And look, we're modern and we have QR codes and everything.
I was actually going to go ahead and post in some of our best practice guides. Like, here's the ones from Veeam, Veritas, and Commvault. In a previous life, I worked on a platform that didn't do deduplication. And when we worked with Veritas and Veeam and Commvault, we always wanted them to provide the largest object to us possible. And my understanding was that came at the cost of data reduction on the data mover. My assumption is that we probably would make up that difference with our global reduction. Do you agree, or?
Absolutely.
So there's several factors going on.
Okay.
Pure object stores are optimized for large objects.
Right.
VAST is a hybrid file system object store database engine and 12 other things. And so we're not specifically optimized just for large objects. We like small files, large objects kind of equally well. And so the problem with writing very large objects is, while with good software you can dissociate the object size from the deduplication chunk size. So one written object would be multiple deduplication chunks. The problem is that when some of the data in a very large object ages out, there's no way to delete part of an object in an object store.
Right.
And so if you write 10 megabyte objects, but the system is deleting on 1 megabyte boundaries, then you might not recover that space.
That makes sense.
Yeah, most objects that are sent up are a bit of a sausage. We've got data from all kinds of things, get them into a vessel, pack them in there, and then they're all in that object, and up they go. So one object isn't necessarily purely data from one data set. It could be
Listeners
scattered.
should assume that the objects that backup apps write are internally much like zip files, that there's data from multiple places aggregated together into that large thing. And so, if you delete some of those files from the source system, you don't get to recover the space on the object store, because you'd have to delete the whole object and write the remaining data again. Looks like we lost Steve.
I think so. Yeah. Adam is deep in thought.
I can jump in for Steve here. I think if there's any more thoughts, Howard or Rob, before we wrap up for today.
I think the main thing is that really optimizing a solution requires knowing what's happening internally in your backup software. What compression algorithm is it using? Is it deduplicating? What kind of scale is there for the deduplication? And what's the effect of turning those knobs on CPU utilization in the clients and the media servers, network utilization, and then assume that the VAST system is going to solve the capacity optimization, as long as you're not sending us that irreducible data. So the encryption and gzip or Huffman coding have to be, just those are the tweaks.
So we had someone in the Q&A bring to our attention that the chat is disabled. Apologies for that. So there is a Q&A section. And so I just pasted those links from Steve into the answered section, which hopefully sent out to everybody there. All of those are available in the white paper solution guides on our site. If you follow that QR code and head into the data protection section. Mm-hmm. I guess for my closing notes would be that ransomware really changes things, and the old mindset of kind of all or none in a data center when you're doing these recoveries, and hey, I'll just fail over to this other site. You have to look at it very different, where the geography isn't usually in question as much. It's logically what's still good, what's not. And then some things can be worked in your favor. So maybe you can just go and wipe a bunch of systems. And especially things like ESX hosts and stuff, you can wipe, a bunch there that are very commoditized to one another, and start clean, and then point back to some good data. So there are a lot of things you can do differently, and all within the same data center without moving out, which is where the versatility of having VAST as your repo not only stores the data, but it can be a live place to recover to. So your data stores can run there at scale, right? You can have copies of things going with products like Zerto or CDP out of like Veeam, or Commvault's got one as well, where we can have a staged copy that's ready to go, kind of like a warm one that you would do over on another site. So you can mix and match all your stuff, and the more that your each buy of piece of infrastructure, the more it can do and do well, the better. It gives you that many more options when you need it.
But I think the key thing to remember about ransomware is that you're going to discover the problem after substantial damage has happened.
Right.
And so, we think about disaster recovery in terms of, well, the power went out at the primary data center, so we'll fail over to the secondary. And event and discovery are almost instantaneous. But when there's a delay between event and discovery, then anything that you replicated, well, that got encrypted too. And the problem is from discovery, figuring out when the actual event happened, because I need to restore from the backups before the first file got encrypted, hopefully before the malware got installed. And so learning that last known good point is the difference. And it is the problem with replication as a solution. It doesn't matter how well you replicate. If you're only keeping 10 days of retention on your replicated copies and you don't discover that data is being encrypted for 12 days, well, now you don't have a good copy and you need to go back to something like a backup that's has longer retention.
Well, we got Steve back here, but I think
I apologize, my network blinked.
No worries. I know we're out of time here, but I encourage everyone that's on the call to, if they want to learn more, if they want to talk to an expert like Howard, Rob, or Steve, to get in touch with us. If you look at the QR code or visit us at fastdata.com, you can get in touch with someone from our team. So thank you everyone for joining us this morning.
Thanks everyone.
Thanks for your time, everyone.
Take care.